How does temperature affect properties of substances? Imagine holding a glass of ice water on a hot day. You notice the ice melting and the water warming up. This simple scene shows how temperature influences what a substance can do. Temperature is a measure of how fast the particles inside a substance are moving. When it goes up, particles move faster and have more energy. When it goes down, they slow down and lose energy. This change in energy affects many properties of substances in everyday life and in science. Let's start with volume and density. When you heat most materials, they expand because their particles spread out. Think of a metal spoon getting longer when heated. This expansion makes the object take up more space and become less dense. Gases expand the most because their particles are far apart already. Water is a special case. It contracts when cooled below 4 degrees Celsius before expanding again. This is why ice floats and why water behaves oddly at different temperatures. Next, consider pressure, especially in gases. When temperature rises, particles move faster and hit the walls of their container more often and with more force. This increases pressure if the volume stays the same. That's why a hot air balloon rises when the air inside heats up. The relationship between temperature, pressure, and volume is explained by the ideal gas law, which shows how these 3 factors are connected. Temperature also plays a key role in phase changes. When a substance absorbs heat, it can melt from solid to liquid or boil from liquid to gas. During these changes, the temperature stays constant even though heat is added or removed. This heat is called latent heat. For example, water boils at 100 degrees Celsius at standard pressure, and during boiling, the temperature remains at that point until all the water turns to vapor. Specific heat capacity is another property affected by temperature. It tells us how much energy we need to raise the temperature of a substance by 1 degree. Different materials need different amounts of heat. As temperature changes, the way particles move can change, which can alter the specific heat capacity slightly. Materials with high specific heat, like water, take longer to heat up and cool down. Thermal conductivity is also influenced by temperature. It measures how well a material can transfer heat. Some materials conduct heat better at certain temperatures. For example, metals like copper are good conductors, but their ability can decrease or increase depending on the temperature. Finally, temperature helps us understand how substances reach thermal equilibrium. According to the 0th law of thermodynamics, if 2 objects are each in thermal balance with a third object, they are in balance with each other. This principle makes temperature a consistent way to compare different materials. So, when temperature changes, it affects how particles move and interact. This, in turn, changes the size, pressure, phase, and heat transfer properties of substances. These effects are fundamental in many fields, from designing engines to understanding weather patterns. Knowing how temperature influences properties of substances helps us control and predict how materials behave in the real world.